Hello everyone, my name is Aristides Carneiro. I'm a flow assurance engineer from Galp and I'm here at Rio Oil and Gas talking about integrated production modeling for field development optimization. We'll start the presentation with an overview of ultra-deep water projects with focus on the Brazilian pre-salt, followed by a discussion on the importance of the integration. Then I will present a case study where you're going to see the implementation of IPM for a specific asset in concept screening, and at the very end, some final remarks. The Brazilian pre-salt is full of assets with unique characteristics. On one side, there are a lot of challenges related to complexity of the reservoirs, complexity of the fluids, complexity of the conditions. We are talking about high water depths and large distance from the coast. Also, the costs involved have very high costs related to well construction and facilities. Nevertheless, on the other side, we have a lot of opportunities. There are world-class reservoirs with huge volumes in place and wells with very high productivities with typically rates up to 30,000 barrels of oil per day. Therefore, and in order to develop this asset, it is quite important that engineers interact with each other in a very efficient manner in order to provide proper production and cost profiles for a robust screening of solutions. And it is from the interaction from reservoir and production engineers that arises the concept of integrated production modeling. This concept enables you to have production profiles that honors all the constraints from pour to process. A novel approach of IPM consists on coupling the reservoir and the production system models in the same interface so that you can reach a solution without an iterative process. Of course, this approach brings you a lot of benefits, starting from the time-saving perspective. In the same amount of time, you can run much more scenarios, which will give you a much deeper understanding of the asset. Second is seamless integration. You can see over time the impact of the facilities into the reservoir, and you can also evaluate over time the flow assurance risks and the plant bottlenecks that you may have. Last but not least, these kind of interfaces can accommodate more software of, for instance, process simulators or even an economical spreadsheet to do the calculation. One of the most important aspects is in regards to the fluid model consistency. For instance, if you have a reservoir model with a black oil fluid and a production system with a composition of fluids, you need to provide PVT delumping tables in order to the fluid can communicate between the two models in an efficient way. Then, in regard to balancing schemes between the reservoir model and the network, you can go for an option that will fulfill the reservoir management strategy but may not accommodate all the capacity that you have in the network, or you can go for a full IPR approach where you can maximize the hydraulic capacity utilization. Of course, the choice between one option or other will depend on the specific conditions of the project and also depend on the question that you want to answer with the simulations. Other very important aspect is to choose the coupling location. One can go for a top hole coupling where you can lower down the CPU requirements, but at the same time we'll need to provide some VFP tables to calculate multi-phase flow within the tubing. Other approach is to consider bottom hole coupling, and in that point you may have simulations a bit slower, but you don't need to provide VFP tables for multi-phase calculation. Again, the decision is a matter of case-by-case selection. The case study that you are presenting here consists on the concept screening for a giant oil field under pre-development stage. We coupled the reservoir model with the production system, and we also consider the process facilities model through the process simulator. The asset has some challenges related to low productivity of the wells and also some risks of flow assurance in regards to risk of wax deposition in the flow lines. Therefore, the question that we want to answer was, what are the most suitable options in terms of subsea layout and artificial lift in order to maximize value on this asset? And our criteria for evaluation was maximization of recoverables, reduction of flow assurance risks, and also reduction of costs. In this slide, we show the outcome of the IPM model in terms of production profiles for two different subsea architectures. And it can be concluded that for this particular asset, well clustering through production manifolds can bring significant value in terms of increasing the recoverables by 8% and reducing the costs by 30% when compared to a standardized pre-salt concept of satellite wells. Also, on a flow assurance perspective, it was possible to optimize the thermal management of the system by commingling production from several wells, something that without the use of the IPM, it would be extremely onerous to be achieved. Another study topic was the screening of the artificial lift option, namely for gas lift. It was studied the impact of the gas lift location that could be in the well, in the manifold, or at the riser base. Not surprisingly, the option for downhole gas lift was the one that brings more value in terms of production optimization. Nevertheless, the other options cannot be disregarded at this point because they also improve production and can compete very well with the downhole gas lift in terms of reliability and cost saving point of view. And in this slide, we show a series of optimization initiatives for the manifolded concept that consisted on subsea configuration adjustments and also on thermal insulation improvement in order to maximize the value for the project. I mean, maximizing production, of course, and reducing the costs of subsea layout and also minimizing the risks of flow assurance. Finally, we could conclude that the use of IPM, we had a higher degree of engagement between the teams. This allows us to have a much deeper understanding of the asset and of the maximization of recovery opportunities. We can now do more robust and comprehensive screening of development concept, and as an overall IPM show a potential to be a powerful tool for decision-making processes, especially for these assets under pre-development stage. And that's all for now. Let me thank you very much for your attention, and I wish you a rest of an enjoyable Rio Oil and Gas 2020. Thank you very much.